Hi guys, my name is Vinay Jain and today we're going to talk about Leetcode question 637, which is average of levels in binary tree. So the question is, given the root of a binary tree, return the average value of the nodes on each level in the form of an array. So what do we have to do? Essentially the question is, so let's assume this is the binary tree that we have. So what is the sum of the nodes at this level? What is the sum of their values? So this is 3. How many nodes are there? 1. So what is the average? 3. So this is the value that we have to calculate. Then we move to the next level, next breadth of the tree. What are the sum of the nodes values in this level? So that is 9 plus 20, right? How many nodes are there? 2. So take the average of their sums. So this essentially comes to be 29 by 2, which is 14.5. And then the average of these nodes values is essentially 5 plus 15 plus 7, that is 27. How many nodes are there? 3. Their average comes out to be 9. So we have to output an array of all these values. So 3, 14.5 and 9. 14.5 and 9. So this is what we have to output. So what is the algorithm for this approach? We'll understand the algorithm for this problem via dry run. As it might have been evident by now, we have to use breadth first search algorithm for a modified version of that to solve this problem. I'll attach the link for my breadth first search video and how it works in the comment section below. Now proceeding with the algorithm. So let's say this is the queue that we have, the pop node, and I'm using some variables where nodes at current level. This essentially means what are the nodes at the current level that we're the count of the nodes at the current level. So if at this level, that means the node of the nodes at current level would be 2, because there are 2 nodes here. If you're at this level, the value of this variable would be 3. So this is to keep track of that. This variable is to keep track of that. And also count of child nodes at next level. So let's assume if you're at this level, the count of child nodes at next level is 2, because there are 2 child nodes next, right? So this value would be 2. If you're at this level, so what is the count of child nodes at the next level? This would be 3 then. So this variable is to hold the number of nodes at the next level. This variable is essentially the same value as this, total level nodes count. So what is the number of nodes at the current level that we are working? This variable is to keep track of that. Level node sum. So this variable is to keep track of the sum of all variables at the current, or sum of all the nodes values at the current level. So if I add this node, this level, so the level node sum would be 9 plus 20, which is 29. If I add this level, the bottommost level, so then this would be 5 plus 15 plus 7, sorry, this is 27. So this would be the value of level node sum. So this variable is to keep track of that. And level average is our list, the required list, which will hold the average of all the nodes at the current levels and their average. So this is the design of our algorithm. So now these are the variables that we're going to be using. Now as we proceed in breadth first search algorithm, we'll insert our root of the tree first to the queue and set nodes at current level 1, because there is only one root, right? So this is the beginning of our algorithm. Now as long as there is something in the queue, as long as there is some node in the queue, we pop that node in the queue, assign it to pop node, and yes, count of child nodes would be 0, because we don't know how many child nodes does the current node have. Total level nodes at the count would also be 1 initially. Level node sum, since we don't know what the sum is right now, it will be 0. And level average would be nothing, empty list by now. So after we pop this element from the queue and assign it to pop node, now we know the pop node's value, which is 3. So we add this to our current level node sum, which is 0 plus 3 gives us 3. So we check if this has a child. How many children nodes does it have? Does it have a left child? Yes, it does. So we increment the count of child nodes by 1 and add the left child to the queue. We check if it has a right child. It does. So we increment the count of child nodes at next level by 1 again, which now becomes a total of 2, and add the right child to the queue. Once we have done this, that means we have explored this node, and then we decrement the value of nodes at current level at 0. That means we have explored one node. So we decrement this value by 1. Now that nodes at current level become 0. That means we have explored all the nodes at the current level, and now we can calculate their average. So what is the total sum of the nodes at the current level? It is 3, right? As we've computed here. So what is the average then? 3 divided by total level nodes count. So this is 3 divided by 1. So this value is used from here. So this essentially gives us 3. So this is the average of the sum of all the nodes in the current level. So our first level is done, then we proceed to the next level. But before proceeding there, we again set, since our current count of child nodes at next level is 2, this would be the next level that we'll be iterating. So this value would essentially be now assigned here, because these are the nodes that we'll be working with at the next level, right? So these are the number of nodes that will be working at the next level, and this value becomes 0 because we don't know how many child nodes does the next level have. Total nodes at current nodes count will also become 2 because these are the nodes that we have to work with in the next level, and we don't know the sum of the nodes at the next level, so we assign this value to 0 for now. Now that we have done this, we pop the queue, the topmost node in the queue, which is 9. We assign this to pop node. Now we know its value. So we add this value to the level node sum variable. So 0 plus 9 becomes 9. So this is the sum so far for the level that we are currently working with. And we have encountered one node, right? So we check if it has a left or right child or not. It has a left child, so we insert that into the queue, increment the count of child nodes at next level by 1 because we have encountered at least one child node at next level so far. Now that we have explored this node and this node cannot be used anymore further, so we decrement the count of this by 1. Now this is the number of nodes left at current level to explore. So now we check if nodes at current level is 0. That means have all nodes been explored or not? No, they haven't. So we again pop from the queue, assign it to pop node, add its value to the level node sum, which is 9 plus 20 gives us 29, and we check whether it has any children nodes or not. It has 2 children nodes, right? So we first add the left child and increment the count by 1, count of child at next level by 1, so it becomes 2 now, and add the child node in the queue, and we also check if it has a right child or not. It does, so we increment the count of this by 1, count of child nodes now is 3, and we add the right child of node 20 to the queue, which is node 7. We add this to the queue. Now this node has been completely explored, so we decrement the count of nodes at current level by 1. Now 1 minus 1 becomes 0. So this essentially means we have explored all the nodes at the current level, and we can now calculate their average. So we calculate their average by how much? How do we calculate that? We have the level node sum information. So what is the total sum of the nodes at this level, which is 29, and how many nodes were there? There were 2 nodes. We have that information here. So 29 divided by 2 gives us 14.5. So we store this in our list and we proceed to the next level. But again, before proceeding to the next level, we again reassign all the values. So nodes at current, so count of child nodes at next level. So this is the next level that we'll be working with. So this essentially value is assigned to this variable here, nodes at current level, because these are the number of nodes that we would have to work with in the next level. And this becomes 0 because we don't know what the child nodes of this next level would be. How many child nodes does it have? This would also become 3 with the same reasoning, and level node sum becomes 0 because we don't know what the sum of the nodes at that level is. So now we'll start working with our algorithm again. Note that nodes at current level, this value is 3. This can be verified from here that we have 3 nodes left to work with. So now we pop the node 5 from the queue, assign it to pop node. It doesn't have any child count, right? So we don't do anything. We just add this to our level node sum, which is, so this becomes now 0 plus 5, 5. And we decrement the count of nodes at current level by 1. So this becomes 2. So this becomes 2, and we have finished working with this. We pop the node 15, assign it to pop node. It doesn't have any child node, so we don't do anything. We add this value to level node sum, which is 15 plus 5, that gives us 20. And we have explored enough, as much as we could, so we decrement the count of nodes at current level by 1. Pop the topmost node in the queue, assign it to pop node, add its value to level node sum, so this becomes 27. No child node, so we don't do anything to this. This remains 0. Nodes at current level is again decremented by 1, so this becomes 0. So now that this has become 0, we can calculate the average of this. So we calculate the average of this how? We have the level node sum information, which is 27. We divide that by the total level nodes count at the current level, so that is 3. So this gives us 9. So these values are essentially our answers. Now we note that the queue has become empty because there is nothing more to add. So our algorithm has terminated, and this is the final list that we have. So the answer is essentially 3, 14.5 and 9, and this is returned by our algorithm. So let's have a brief overview of the algorithm. As discussed, the algorithm is, while queue is not empty, there is some node in the queue. We pop that node from the queue, add the pop node's value to the level node sum to keep track of what is the sum so far that we have encountered for the current level. If pop node has left or right child, add the child to the queue and increment count of child nodes each time. So each time you enter the left node, increment count of this by 1. If a right child exists of the current node, increment the count of this by 1. Now that we have explored the current node, decrement nodes at current level count by 1. If no more nodes left to explore at next level, that is essentially when our nodes at current level value becomes 0. That means we can calculate the average sum of the current level, right? So we calculate the average sum of that and add that to level average list. Then the number of nodes to explore next, that is essentially nodes at current level, that is set to the value of count of child nodes at next level, because these are the number of child nodes that we'll have to iterate next, that we'll have to work with next. Similarly, the same changes made at this variable here, total nodes at next level, they are also the same as count of child nodes at next level. Now the count of child nodes, the variable, that value will be assigned to 0, and the new level node sum for the next level will be 0. And this is how we keep iterating until and unless our queue becomes empty. And once it does, at the end, we return our level average list. So this is essentially the algorithm for the problem. I hope this video helped you understand how to solve this question. Thank you for watching this video. Have a nice day.